Animation aficionados, lovers of LEDs, and Python peeps, this is CircuitPython School with Prof G, and this is the lesson where your CircuitPython skills will truly dazzle, because we're going to use the Adafruit LED animations library to create super cool animations that are super easy to implement. Let's learn big. So let's begin by plugging our LED strip into pad A1, then plugging your Circuit Playground board into your computer, launch PyCharm, and if you're new here, welcome. You may want to check out the earlier lessons in the playlist so you know how we got here. CircuitPython libraries contain lots of great code developed by others that simplify complex tasks and make it easy to do really cool things. A great library for those wanting to work with LED lights is the Adafruit_LED_animations library, developed by the truly exceptional Kattni Rembor. And in this tutorial, we're going to copy and paste lines of code from the Adafruit Learn Guide from this library, which you can find by searching for Learn Guide CircuitPython LED Animations. So find that guide, pull it up. The left-hand side has a bunch of links where we can jump to specific sections of the tutorial. The Import and Setup section says that we need to make sure that our LIB folder on our board has both the Adafruit_LED_animations and NeoPixel libraries installed. And remember, you can install this using CircUp. Just open the PyCharm terminal, and at the prompt, enter circup install Adafruit_LED_animation and press return. You'll see the install progress through the terminal. Everything should install fine, and if you don't have circup installed, again, check out the earlier lessons in the playlist. Now I've deleted everything from my code.py file in PyCharm, but I'm going to start with a comment that says using -Adafruit_LED_animation.py. That's what we'll eventually save this code as. Then we'll import board, NeoPixel, time. And I also want to import the built-in colors that we used in a previous lesson. So you can find that by heading to a browser and typing in bit.ly/CircuitPython-colors. You'll remember this is just a Google Doc so that you don't have to type in this long line of code to import these colors. Copy this line here from through black. You can head to PyCharm, paste it in underneath your import statement, and I'll put the \line continuation character just before blue and press return so I can get this on 2 lines. And below this, let's create a list of all these colors. So we'll call that colors. We'll say it equals, and in between square brackets, I'm going to paste that same line that I just copied, but I'm going to delete the front part from through import. Those aren't colors. And to get this on 2 lines, I don't need the / character because Python will indent this just below red, the first element in my list, so I can press return just before aqua. Looking good. I've got my colors red through black in between square brackets. Then let's create some NeoPixel objects, and I'm going to break out the number of lights as a separate variable. So first I'll say pixels_num_of_lights and set this equal to 10. Then for our onboard NeoPixels, we will, as we have been in the other lessons, call this pixels, set it equal to NeoPixels.NeoPixel N and in between parentheses, we'll pass in board.allCapsNeoPixel, comma, and for the number of lights, this will be pixels_num_of_lights. And just to make sure we don't have any problems with overloading the board, we'll write brightness equals 0.5. Then down below, to set up our NeoPixel strip, we'll create a value called strip_num_of_lights and set this equal to 30 because there are 30 lights on our strip. And we'll call this NeoPixel object strip, setting it equal to NeoPixel.N NeoPixel, and in between parentheses, this is going to be board.A1 because we clipped our lights to signal pin A1, comma, and then we'll pass in strip num of lights and say comma, brightness also equals 0.5. Then just to turn off all the lights each time we restart our code, we'll say pixels.fill in parentheses all caps black, strip.fill in parentheses all caps black. And I like to put in a print statement before my while true just so that I can take a look and see this output so that I know that my code is running. So I'll say print and in parentheses the string animation code is running. I'll enter while T true : and let's head back to our browser. Now this area here in colors covers the colors that we've already imported. Now let's jump to basic animations. Now solid just shows a solid color. It's not really an animation, but if you ever need to create an animation sequence, like we'll show later, that has a solid color in it, you can come back and use this function. But I say let's start with blink. Now just like we did when we worked with colors, we're going to use from import to import something from this library. This line here, from Adafruit_LED_animations.blink import blink, is the line that we want. And this will import the blink class. Again, a class is like a blueprint that we can use to create code that in this case will blink. So let's highlight that line, we'll copy it, We'll return to our code and we'll paste in our animation imports just above our color imports from the prior lesson. Then return to the Learn Guide, we'll scroll down to find out how to implement blink, and we're going to grab this line here, which creates a blink object from the capital B blink class. So copy this line, and note just below this, we're going to need this code later too. This is where we call lowercase b blink.animate in our while true loop, and that gets the blink to repeat. Now back to our code. And just before this print statement, before the while true loop, is where I'm going to set up my Adafruit animations, and I'll paste in the code that I just copied. There's more information about this statement in the Learn Guide, but what we're doing is we're creating a variable, lowercase b blink, that will hold an object that we animate to create the blink animation. And to do this, we'll set lowercase b blink equal to uppercase b blink. That's the class or blueprint that creates the blink object, and the values that we pass into the class for creation of the object are the name of the LEDs that we're animating, in this case it's pixels. The Learn Guide also names the pixels that it's working with as pixels 2, just as we do here, so we don't have to change anything in this line to work with the 10 lights on our CPB. The speed argument says that we're going to blink on or off for half a second, and the color equals jade is the color we're using to light up the group of LEDs that are named pixels. Now this code creates our blink object from the capital B blink class. Down in the while true loop, we actually have to call that object's animate method. Remember, a method is a function associated with an object, and that will animate the blink. So we do that by saying blink lowercase dot using dot notation animate with open and close parens, then open the console, make sure you're in TO, save, and will you look at that, my CPB lights are blinking in the color jade. So since we haven't gotten the light strip name strip to blink yet, that's our challenge problem. And if you don't have a light strip, you can skip the challenges and any code that refers to strip, but in class all of my students have LED light strips, so they've got to follow along and write code to create another blink object. Why don't we call this blink underscore strip so that it'll match the solution code that I'll demonstrate, and then use blink underscore strip to simultaneously blink the neopixel light strip that we call strip in the color amber, so that when you're done you should have something that looks like this video where the lights on the board are blinking in jade and all of the lights on the light strip are blinking in amber. So why don't you pause, give that a shot, resume, and let's compare answers. So since we need to create another object from the blink class, I'm going to highlight this line where I say blink equals capital B blink, copy it, paste it down below, then I'm going to change the name of the object to blink underscore strip. And since this object is going to point to the strip, I'm going to change the pixels argument inside of parentheses to strip. Then down in while true, we're going to add blink underscore strip dot animate with open and close parens. Oh yeah, and for blink strip, we've also got to change the color to amber, all capitals. Open the terminal with TO, save, we have no errors. And look at that, we've got blinking in jade and amber. Nice work. This is fun. Let's add more animations. So we'll return to the Adafruit Learn Guide, and this time let's import ColorCycle. So let's highlight and copy the from import line here, return to our code. We'll paste this under where we imported our blink, but I'm going to comment out the animate calls to these two objects down in the while true loop. This way we're only going to animate the ColorCycle animation, and again highlight and command / toggles on and off comments. Then we'll return to the Learn Guide. We'll find and highlight and copy this line that creates the ColorCycle object from the ColorCycle class. Then back to our code. Why don't we paste that below where we created our blink objects? And remember, the lights on the board are called pixels, so this is fine, but let's change the colors parameter that allows you to pass in a list of colors between brackets. This is a selection of colors that was created as part of the Learn Guide, but we've already got a list of a bunch more colors that we created in an earlier lesson. So let's use that colors value that we have up here. I'm going to highlight and copy the word colors, and actually I'm also going to change the blink time from half a second, which was included in the statement that we just copied, and I'm going to bring that down to 0.1 seconds so it flashes faster in just 1/10 of a second increments. Then I'll highlight this list that includes the double brackets, and I'll paste over that with the word colors. Now, when you look at this, it looks kind of weird, but this code will work. The first colors in this statement is the name of the argument to create a property named colors inside of the ColorCycle class, and we're saying that equals colors, and this colors here is that variable colors that we created in our code, which is the list of a bunch of different colors. These two color references won't conflict with each other. They're considered to be two separate things, so this is a valid statement. And then I'm going to copy the statement that I just modified. I'm going to paste it below, and we'll create another ColorCycle object to work with our light strip named strip. So I'll name the second ColorCycle here, changing the name to ColorCycle underscore strip, and I'll change pixels in this call to strip so that we create an object using the light strip. I'm going to keep everything else the same, so at this point we have two ColorCycle objects. Now remember, we need to animate them in the while true loop, and we do that down here. We can call ColorCycle.animate, and ColorCycle underscore strip.animate. And I saved before opening the terminal, but no errors. And look at that. Both the pixels on our CPB and the strip that's attached to pad A1 are cycling through all the colors that are in our colors list that we created in our earlier lesson. Nice work! So next up is our chase animation, and be aware that although I'm demonstrating what I always think are nice ways to implement these animations, most of these animations have additional arguments that can be included, and all of the arguments are described in detail in the Adafruit Learn Guide. Feel free to dive in and explore those on your own. So now chase is a way that we can implement a light chase, a group of single colored lights moving around the LEDs. By the way, these animations in the Learn Guide show the same code animating a matrix or a rectangular block of lights instead of lights on our CPB ring or the strip. This one happens to be using a NeoPixel feather wing attached to a feather board. And yes, you can use the same code on a rectangular block of LEDs if you ever want to try something like that in the future, but we'll keep working with our ring of lights on the CPB in the light strip, but first let's implement the code that we've got here, and by now you know the drill on how to implement chase. First, highlight and copy the import statement mentioning the chase class. We'll paste this in our code just below our other animation imports. Then let's scroll to the bottom of the code, and why don't we comment out the calls to our ColorCycle animations in while true, and I'll make room in while true for the setup of the chase objects. We'll return to our Learn Guide, find and highlight this line that creates the chase object from our chase class, and then I'll paste 2 copies of that into our code. I'll change the variable for the second one to chase underscore strip, and I'll make sure the chase class calls strip instead of pixels. And in while true, I'll also make sure that I call chase.animate and chase underscore strip animate. Make sure you got parens after those. Then I'll open the terminal. I will save. And we have a basic chase animation. And if we look at the arguments we used to create this, the color's white, the size of the group of lights that's turned on is 3, and the spacing in between the groups of lights is 6. Now, I mentioned we could also create something that I think looks a little bit nicer, the theater marquee lights. That's where alternating groups of single lights seem to chase each other around and around. Why don't we set that up just on our light strip? So in the chase underscore strip line here, I'm going to change my spacing to 1 and my size to 1, and then I'll go up and click on save, and now we can compare what happens here. We can see that those lights are chasing round and round, and the group of lights is just a single light with 1 space in between each light. Looking fancy. Let's move on to the next animation. Up next is one of my favorite animations, Comet, because if implemented in a certain way, it can mimic, if you're old school, the kit car from the old Knight Rider series, or a bit less old school, Cylons from Battlestar Galactica. This kit car Cylon effect is sometimes referred to as a Larson scanner. That's after Glenn Larson, the guy who created the effects for these TV shows. So we'll grab the sample code, change things up, and we'll eventually end up with a Larson scanner. So we'll find and highlight the from import line for the Comet class, then return to our code and paste it in with our other from imports. Then in while true, I'll comment out my 2 chase animations. Then we'll return to the Learn Guide, find and copy the line that creates a Comet object from the Comet class, and I'll paste this into our code. And for starters, I'm going to change the bounce property to false so that we can see what happens when it doesn't bounce. And I'll change the object name in the second line to Comet underscore strip. Then I'll change pixels to strip so it works on the NeoPixel strip. Then down in while true, I want to call Comet.animate and Comet underscore strip.animate. And we'll save. And whoa, that's going a little fast. I'm going to change the speed from 1/100th of a second to 1/10th of a second. I'll do that both in Comet and in Comet underscore strip. Then save again, and we can get a better sense of what this animation is doing. So there we see we have this Comet animation where the first light is very bright and the lights progressively dim until you reach the end of the tail. Well, that's cool, but why don't we implement the Larson scanner? And the Larson scanner is always in red, so I'm going to change both colors to red. The Larson scanner bounces, so I'm going to change the bounce to true in both lines. And in the Comet underscore strip, I'm going to change the tail length, and I'm going to perform a calculation which is going to be int, and then in parentheses, it'll be strip underscore num underscore of underscore light, so strip num of lights divided by 4. So if the numbers divide evenly, the tail will be 1/4 of the size of the strip itself. And remember from our earlier video, putting it inside of int makes sure that we don't get an error if it's expecting an integer in here and we somehow have a decimal or a fraction that results from this equation. I'll also speed things up a bit. I'll set the speed to 0.05 seconds, then click on save. And ho! Call Hasselhoff and alert General Adama, we've got a Larson scanner. Nice work! Up next is Pulse, where all the lights pulse up from off to full brightness, then back to off again. We'll highlight and copy the from import for Pulse. We'll paste it into our code up where we have our other from import statements. Then further down in the code, let's make room for creating pulse objects. Then head back to our Learn guide. We'll find, highlight, and copy the pulse equals pulse code that creates the pulse object. Return to our code. Paste that in, and for our first pulse, why don't we change the speed to 0.05 or 5/100ths of a second. This will give us a smoother pulse. I'm also going to change the period to 2. That will be 2 seconds for the entire pulse to go from start to finish. So a smaller speed means a finer grained transition during the pulse. The pulse will look smoother, while the period is a length of time for a single pulse. Then in the pulse line I pasted below, we'll change pulse to pulse_strip, change pixels in that line to strip, also set speed here to 0.05. And I'm going to change the color here also to blue, so pulse_strip is in blue. And the period at the end should also be equal to 2. And then in the while true statement, we should comment out our last 2 animations, and we can call pulse.animate and pulse_strip.animate, and save. And look at that magnificent pulsing. Perhaps you think this is soothing and would create cool mood lighting. Well, you've got another animation in your repertoire, but there's even more. Now we're going to add Sparkle and SparklePulse animations. Now these are in a separate link, so let's scroll up and then find the Sparkle link on the left-hand side and click that. I think Kattni broke this out in a separate page because Sparkles I don't think work on boards that have slower processors, but the CPB that we're using has plenty of juice to handle this animation, so let's give this a try. We'll do Sparkle first, find, highlight, and copy the from import for Sparkle, then return to our code and we'll paste it up top by our other from import statements. Then down in while true, I'm going to comment out our last 2 pulse animations. Then I'll make space above while true for our Sparkle objects. And then back to the Learn guide, find, highlight, and copy the Sparkle equals Sparkle line that creates a Sparkle object from the Sparkle class. And then return to our code and paste that in. And I'm going to find and get rid of the num of sparkles attribute at the end here. And I'm doing that based on some info from the Learn guide. If you go back to the Learn guide, you'll see that num_sparkles is optional, and if it's not there, it defaults to 5% the length of the pixels object, meaning the length of the LED strip or the number of lights on our board. And I really like that setting, plus we don't have to calculate any special value in here because the calculation's automatically done by the library. So we're going to leave this optional value off. Do feel free to dive back into the Learn guide and experiment with some of these values. There's lots of good info in there. But for now, let's head back to our code. I'm also going to change the sparkle color to purple. And then I'll copy this line, paste it below, change sparkle in the pasted line to sparkle_strip, and change pixels in the pasted line to strip. And then in while true, I'll call sparkle.animate and sparklestrip.animate and save. And will you look at that, you get a beautiful sparkle effect. That'd look great in a wearable. My youngest daughter attached an LED light strip inside the hem of her dress, and she was the talk of a dinner that we went to together. Now let's comment out the 2 sparkle animations that we just created because there's another animation for us to use in the Sparkle family. This next one is called SparklePulse, so let's give it a try. Back to the Learn guide, and SparklePulse will pulse the sparkling light. It's a bit less abrupt of a flash than the sparkle animation we just did. So first let's highlight and copy the from import line for SparklePulse. Return to our code. We'll paste that in up top near similar statements. Now frankly, I'm not sure why we're getting the red squigglies of anger in here. I probably need to import some sub-library. It seems that PyCharm isn't recognizing the class SparklePulse, but you'll see this code will work. Then down below, just before while true, we'll make room for our SparklePulse objects. Then we'll head back to the Learn guide. We will find and copy the SparklePulse equals SparklePulse line for creating a SparklePulse object. Return to our code and paste this into the space above while true. And to show you the effect I like, I'm going to set the period to cycle through this animation to 5 for 5 seconds. I'll set the color to blue. Then I'll copy this line, paste it below. I'll change SparklePulse to SparklePulse strip. Change pixels to strip, then back down in while true, we'll call SparklePulse animate and SparklePulse strip animate, save, and we see a sparkle animation that's a bit of a gentler pulse. It's up to you to decide when you'd like to use either of these options, and we can continue to be dazzled by animations because next up we have 2 rainbow animations to implement. Now back at our Learn guide, the rainbow animations are in a separate page, so scroll to the top, find and click the rainbow link on the left-hand side, and we'll first implement rainbow. So find, highlight, and copy the from import from rainbow. return to our code, paste it in the usual location for our from imports, scroll down, and as usual, make some room above while true for our rainbow objects, return to the browser, find, highlight, and copy the rainbow equals rainbow line that will create a rainbow object from the rainbow class, return to our code, paste that in, and I like this animation when the speed is 0.05, so I'll change the speed to that. Then I'll copy this line, paste it below. In that new line, I'm going to change rainbow to rainbow underscore strip, making sure that I call strip instead of pixels. Then down in while true, I'm going to comment out our two SparklePulse animations, and I'm going to add a call to rainbow.animate and rainbow underscore strip.animate. Save. And ho, whether you're prepping for a rave or getting ready for Pride Month, you have got serious rainbow action in your LED lights. Nice work, but there is yet another rainbow animation for us to try next. That's the RainbowChase. Head back to the Learn Guide. Here's a look at the kind of animations this can create. Find, highlight, and copy the from import statement. Return to our code. Paste this near the start. Scroll to the bottom. Let's comment out our rainbow animations from the previous example. Let's make room above while true for our RainbowChase objects. Back to the Learn Guide. Find, highlight, and copy the RainbowChase equals RainbowChase line that creates a RainbowChase object. Return to our code. Paste this above while true, and feel free to experiment with the animation parameters, but I like a speed of 0.01, a spacing of 0 so there isn't any space between the rainbow colors, and I'm going to add a parameter in here that's the step value, and I'll set that equal to 8. Now here's what step equals 8 means. There are 256 different combinations of colors that take you through the rainbow. That's something in CircuitPython called the rainbow color wheel. That's different from the combinations of RGB that you can get. If we went through all the RGB colors, well, there's 16 million of those, and those are too much to cycle through. And a step of 8 means let's go through those different colors 8 steps at a time. This will make it a little bit easier to see the differences between the colors. Again, feel free to experiment with any of these parameters to see how you can tweak the RainbowChase animation. But what I'm going to do is I'm going to highlight and copy the RainbowChase line, paste it below. I'll change RainbowChase to rainbow underscore chase underscore strip, change pixels to strip. I'm going to change the step to 20 for the strip, but again, feel free to experiment with these values on your own to see how a change can make a difference. Then we'll call rainbow underscore chase.animate, rainbow underscore chase underscore strip.animate. Let's open the terminal and save. And look at that, the cycling rainbow is truly magnificent. Where rainbow lit up all of the lights in the same color, now we can see different rainbow lights chasing around our LEDs. You are gaining skills. Now it's time to put all these animations together, and we can do that with an animation sequence. Let's do it. Now the animation sequence has its own page in the Learn Guide, so let's scroll to the top. Then on the left-hand side, find animation sequence and give that a click. And the animation sequence lets us string together several animations and let them play one after another. Now we can set several parameters in here, including how long the individual animations will take, and we can even elect to show the animations in a random order. Let's set up an animation sequence using all of the animations that we've created in our code during this lesson. So first, let's grab the from import statement for animation sequence, highlight, copy, return to moo, paste this in toward the top of your code, then return to the Learn Guide, and if you scroll down, you can see how animation sequences are set up. Now this line here creates a value called animations using the animation sequence class, and it passes in 3 animations separated by commas. We can actually pass in many more than just 3, and we'll do that in our code in just a minute. But in this example in the Learn Guide, they're just passing in the animations for Comet, Blink, and Chase. So let's copy this entire chunk of code from animations through the closing parenthesis, return to our code, and we'll paste this in down before the while true, and I'm going to delete the Comet, Blink, and Chase animations, and instead I'm going to enter all of the animations that we've created in the order that we set them up, separating each one by a comma. So those are Blink, comma, ColorCycle, comma, Chase, comma, Comet, comma, Pulse, comma, Sparkle, comma, SparklePulse, comma, Rainbow, comma, RainbowChase. These are all lowercase. Make sure that you've got the spelling correct, because if you don't, you'll get an error. And I'm going to put a backslash line continuation character just before RainbowChase and press return so I can see both of these on 2 separate lines so I don't have to scroll. Now I'm going to keep the advance interval as 5. That means that there's going to be 5 seconds for each animation in the list. I'm going to keep auto clear as true. That clears out the lights after each animation, and you usually want to do that so that you don't have any residual lights that are lit up from the old animation lingering in the new animation. But I am going to delete the random order parameter. Now the default is false, so if you delete this parameter, it just sets it to false, so it will not randomize, and we don't want it to randomize here. You can go and add randomization in later on if you want to try that out. Then I'm going to copy this entire animations block that I just created through the closing parenthesis, paste it below. Then I'm going to add an underscore strip so that I can set up an animations underscore strip sequence for my LED light strip. And I've also got to add the underscore strip after each of the individual animation names. So when you're done, you should have blink underscore strip, ColorCycle underscore strip, chase underscore strip, comet underscore strip, pulse underscore strip, sparkle underscore strip, sparkle underscore pulse underscore strip, rainbow underscore strip, rainbow underscore chase underscore strip, and you'll have them all. Make sure you spell them right, double check your work. And you can see I adjusted my backslash as my line continuation character so I can see this all on the same screen. This now spreads across 3 lines on the screen. Now down in the while true loop, we're going to make sure that our last 2 animations have been commented out, but we're going to add a call to animations.animate and animations underscore strip.animate. So one last time, let's open the terminal and save. It saves okay, and look at all of those different animations running through, one after another. Truly exceptional work, programmer. Bask in the glow of the fabulous LED creations that you've worked on. There are a few more things in the Adafruit LED animations library that we haven't covered. There's pixel mapping, which allows you to do things like have several LED strips animating together as if they were a rectangular LED matrix. There are also animation groups that are useful if you need more control executing different animations on different groups of LEDs. But we've covered a ton in this video, and this works great for the equipment that my students are using in their class. Before we finish up, let's be sure to save this to our CircuitPython School folder as using-adafruit_LED_animation.py, and we'll close that outermost tab. So I hope you feel like the LED magician that you've truly become. Keep at it, coder. There's lots more goodness to come.